Hello, my name is Sobrino, and today I will be presenting the Rust programming language for my Fundamentals of Programming class. Here we go. So, a quick overview of what we're going to be covering today. I'm going to be covering the Rust programming language, what is the purpose of Rust, the language structures such as the variables and the functions, the biggest key of Rust, which is the memory safety, Rust in the industry, and finally the future of Rust. So let's begin with the Rust programming language. The Rust programming language was founded in 2006 by a research employee who goes by Graydon Hoare. This is his picture here on the right. So Graydon Hoare actually had an anecdote about an elevator in which he one day he was just going over to his apartment and he saw that the elevators were always broken. So as a computer scientist and a software engineer, he knew how the programmers programmed the elevator. And he knew that even though they were using low level programming languages like C and C++ to program the elevator, that there had to have been something wrong with the way it was coded for the reason why it was breaking. So he deducted that the reason why was because of the memory bugs that the code of the elevator had within its system. So he decided to develop a language which prioritized memory safety and safe code. So when he started developing this, it didn't have much traction. He started off, just as a normal employee in Mozilla. However, as the project grew, Mozilla took initiative and actually started sponsoring this language because of its functionality, and they gave Graydon an opportunity to grow, and they started funding it in 2009. And they actually Mozilla themselves implemented it in its own browser, which is Mozilla Firefox, and also another browser, which they worked on. So when Graydon Hoare was asked about the name of Rust, why he chose it, he said that he believed that he named it after a fungus. And why is that? It's because he just thought that fungi are over-engineered, just like his programming language. So let's move on. So what is the purpose of Rust? So the key goals and concepts of Rust are safety, like I mentioned earlier. So it has memory safe programming, and it has implementing ownership and borrowing, something that I will go into in a little bit. The performance of Rust is actually very high performance. It's comparable to other low-level languages like C and C++. And it has fearless concurrency. So it enables early detection of many concurrency errors at compile time rather than at runtime. And once again, it has no garbage collection because of the ownership system. And why should we use Rust? Well, first of all, the memory safety, and it also just empowers the developers to write safe and reliable and efficient code. And it also eliminates the trade-off between safety and control. So you don't have to be as worried about as what could your code do in the safe slide. So the language structure of Rust is reminiscent of C and C++, which gives developers an easier time to adapt to the programming language. The language was also optimized for readability, and Rust is actually statically typed, which means that it requires explicit declarations of data types before compilation. Other statically typed languages include Java or C, but let's go on to the variables. So something really interesting that I found in Rust is that variables are actually all immutable by default. And in order to change the immutability of a variable, you must hard type it. You must type in the keyword mut. So variables are declared by the keyword let, and like I said, they're immutable. And if you do want to change them, which means you want to make them mutable, you must include the keyword mut. This immutability also allows for just safety overall and concurrency in the language. So now I'm going to move on to the language structure, which is the functions, or sorry, the data types. There we go. So in Rust, we also have arrays. Like any other language, we have booleans and we have numeric operators. Our arrays are really similar to the declaration arrays of C++ and C, except here they're using square brackets instead of curly brackets. The booleans are also really similar. You have either true or false, and the booleans in Rust take 1 byte in size. And the numeric operators of Rust are the same that you would find in any other language. So addition, subtraction, multiplication, division. You also have remainder, which is called modulo in some other languages. Um, Now we have functions. So functions in Rust use snake case as the conventional style for function variable names. Functions are declared using the fn keyword along with the name of the function in snake case with an opening and closing parentheses for parameters and curly braces that give the function a body structure. Just right off the bat, you can tell this is really similar to other languages. Just the structure of Rust was made to give the programmers a sense of familiarity and good readability all throughout the language. So the key feature of Rust, memory safety. How does Rust achieve memory safety without relying on garbage collection? So Rust implements this system called ownership and borrowing. So Rust introduced the concept of ownership, which each piece of memory has a single owner. And in order for other things to access that piece of memory, Rust has a borrowing system, which allows references to the data without transferring ownership. So to give you a quick analogy, let's think of a car, your car specifically. So you have a car, right? And that car only has one driver, and it's you, right? You're the owner. However, let's say that your friend wants to use your car because they need to go and run some errands. So you let your friend borrow the car, but that's about, sorry about that. Let me just go back here. So to continue on with the analogy, your friend wants to borrow the car, so you let them. And as soon as they're done with it, he gives it back. That's essentially how the ownership and borrowing system works. So there is only one owner of the piece of memory, and if let's say you call that piece of memory later on in your code, all it does is just borrow it, and once it's done, it simply just gives it back. That is a very simple analogy of how the ownership and borrowing system works. And so let's move on. So the Rust language in the industry is already used by some big names that you might recognize, like Mozilla, its, I guess, founder, AWS, which is cloud services, Dropbox, and Figma. So in Mozilla, it's used to improve the performance and security of its browser, and also enhances the performance of the browser as a whole. Within AWS, it does have varied use. It is implemented in many different areas. However, it does have great potential in cloud computing and is almost endless the amount of implementations that you could use with Rust. In Dropbox, it's used to enhance efficiency and maintainability within its low-level code. And in Figma, it's used in its backend to handle operations that require low-level control, and also it improves its efficiency. So let's talk about the IDE support. So Rust has really good IDE support, and there are already many of them which provide Rust-specific features to enhance a developer's experience. So some of the IDEs that can be used to write and compile Rust are VS Code is a really popular one. I actually used it to start my own Rust project, and that is how I was able to gain familiarity with it. There is IntelliJ IDEA, which is also a very, very popular IDE. It's used out in the field specifically with many high-level programming languages. Eclipse, which is also a household name at this point in between the IDEs, and Atom as well. However, you do notice that with IntelliJ, Eclipse, and Atom, and as well as VS Code, you do need to implement some plugins in order to have Rust compile. But those steps are very small, and it should be very simple to set up as well. And like I said, yeah, these are some of the most popular IDEs out there. So you can run Rust in any of these. The future of Rust. So we've gone to the final slide. Rust is a language that is growing in popularity in a mass scale. Rust was actually the most popular, and I believe it still is, the most popular and beloved language among Stack Overflow, which is the largest database of, I guess, like a social media um, for developers. Um, and that is it's a really big thing because that means that developers really, really like Rust, which means that it will be implemented in more and more big software in its future. Specifically, the memory safety part of Rust is what gives it that amount of popularity, and the fact that it's just been picked up by the community so quick, and it has been backed by them. It gives it a really, really good future proof. But that would be it on my presentation of Rust. If you do have any questions, please let me know in the discussion board. I'm more than happy to answer questions about Rust and just to give out some examples, there is a in the documentation of Rust. I'm actually working on this right now. It teaches you how to make a web server, and I thought that would be really interesting to help me get into the backend of things, specifically utilizing Rust. Thank you for watching the presentation. Have a good day. Bye bye.